Hi everyone, we're talking about power series today. And a power series is a series of this form. We're going to have like maybe a constant or something going on here. We're going to have our variable maybe minus some constant to the n power. Okay. And so this constant right here is going to be where our series is centered about. It could be 0, it could be some number, right? So here minus c, minus c, minus c. If you see that, then you know that it's centered about that constant. So for instance, up here, I have x minus 5. Okay, that means that my series is centered at x equals 5. So we have our statement of our domain and such, but really the big thing we're going to focus on is convergence. So the series is always going to converge about the point that it's centered. Okay, so it's always going to converge at C, whatever our center is. And so we don't really have to worry about that. Okay, it could diverge everywhere else, but it will at least converge at C. Now, it could converge for some interval, okay, for some radius, we're going to call it later, which we call R, or it could converge for all real numbers and it could behave real nice. Okay, so either it behaves real nice, converges for all numbers, it converges for some numbers, or it only converges for one number. Okay, and we're going to get some radius, and our radius could be all real numbers, meaning that it converges for all numbers. It could be 0, meaning that it only converges for one number. Okay, and so from our radius we can find an interval of convergence. The nice thing is we're going to use the ratio test, which you already know. Right, so behaves very similar to series, Taylor series in that way, or series which we did before. Let's do an example. So I'm going to start by doing the ratio test. Hey, I'm not even going to bother writing the negative ones because those will cancel and I have absolute value bars, so don't really have to worry about that. Okay, and then we're going to multiply by my reciprocal. Okay, so I've written out my ratio test. Now I am going to simplify a little bit, just write some terms out. Okay, and things should always cancel, which is why we like this test. And so I'm left with my limit as n approaches infinity of x minus 5 times n divided by 2n plus 2. Okay, so I just distributed this 2 to my n plus 1 right there. Okay, and so as I approach infinity and my powers are the same on n, okay, my variable is not x, it's n, then I know I compare my coefficients. And that's kind of the weird thing right now. One of my coefficients has a variable in it, but that's totally fine. Okay. So what I want out of the ratio test is I want my limit to be less than 1. Okay, if it's less than 1, that means that it converges. So I'm trying to see where this is less than 1. That tells me where it converges. So if I evaluate my limit, okay, that tells me that essentially x minus 5 divided by 2, I'll write that a little better, x minus 5 divided by 2 is less than 1. Okay, it has to be less than 1 for this to converge. Okay, what that tells me is that x minus 5, the absolute value of x minus 5 has to be less than 2, which means that x minus 5 has to be less than 2 and greater than negative 2. Okay, so you can kind of see how right here I have what looks like an interval, right? Or you could think about it as a radius, okay? I'm going 2 in this direction, 2 in that direction. Now I'm centered at 5, so I'm going to add 5 to all 3. Right, so I end up getting 3 is less than x, which is less than 7. Okay, so that makes sense because I was centered at 5, and I ended up having a radius of 2. So being centered at 5 and then 2 in each direction, I find that I'm convergent. Okay, so my radius was 2. Okay, that's what I found right here. My radius of convergence. Right, and then my actual interval of convergence is between 3 and 7. Now, what I have to do at this point is check both 3 and 7. All right, so I'm going to clear some space. Now I have to check x equals 3. Okay, the reason why I have to do that is because right now, okay, this is my answer. However, it could converge at 3 and it could converge at 7, and I'm not really sure if it does or not. So you kind of have to check this by hand. And the way we're going to do that is just by plugging in 3 for x and seeing what happens. Right, so I'm going to check x equals 3. Okay, so I have my series from 1 to infinity, -1 n plus 1, -2 to the n over n times 2 to the n. Right, so I plug 3 in for x, so 3 minus 5 is -2. Okay, we'll do a little bit of simplification here. So what I'm going to do is split this up. -1 to the n and then 2 to the n. And the reason why I want to do that is so that some things can cancel. I'm actually going to combine these two terms right here. So I get -1 to the 2n plus 1 divided by n. Okay, now this might look kind of weird, but if you write out some terms for this, okay, you end up getting -1 over 1, minus 1/2, minus 1/3, minus 1/4, minus ... All right, so what ends up happening is that this is the harmonic series. All right, so it's the harmonic series, but every term is negative, but that doesn't change the fact that it is the harmonic series, or you could think about this kind of like a p series, just with a negative in front of it, right? But this is the harmonic series. Hey, kind of like in reverse, or it's negative, or however you want to think about it, but it's still divergent. All right, so I have 1 over 1, 1 over 2, 1 over 3, 1 over 4. Okay, they're all subtracting. Normally in the harmonic series, they're all adding, but the fact that they're all negative still means that it diverges. Okay, now I'm going to check my other endpoint, 7. All right, so same thing, and you might be able to guess what's going to happen. When I plug 7 in for 5, I end up with 2 to the n. So right off the bat, these are going to cancel. And I end up with something that hopefully looks familiar. Right? So if I write out some terms of this, I see that my signs are alternating. Okay, this is the alternating harmonic series, which is convergent. Okay, I know that. I don't have to prove it. For harmonic and alternating harmonic, you don't have to prove it. These are known to be divergent and convergent. All right, so I know that it converges if I plug 7 in, so I can't just put a less than sign. I have to put a less than or equal sign. Okay, what that tells me is that I'm convergent every number greater than 3. Okay, I'm not including 3 because if I plug 3 in, I get the harmonic series. Right? I'm convergent for every number greater than 3 and every number less than 7, including 7. So if you plug any number in between 3 and 7, including 7, in for x, you will get a convergent series. Okay, that's what we just found. All right, so this is my interval of convergence. Yeah, that's what I just found to be my interval of convergence and my radius of convergence. And my radius of convergence is r equals 2, which is what we found at a previous step. All right, kind of a long process, but let's move on. All right, let's try another one. Now again, we're going to do our limit to infinity. Okay, so ratio test. All right, again, I'm going to ignore this -1 for now. So I have x to the 2n plus 1 over 2n plus 1 times, and then the reciprocal. All right, so this one's a little weird, what's going on here. So why don't we do a little bit of simplification? All right. So we're going to end up with, I'm going to distribute this. So 2n plus 2 plus 1 is plus 3. And then same thing here. I have 2n plus 2 plus 3. And I'm going to go ahead and split this up. Okay, so what's going to end up happening is some things will cancel again. I'm going to go ahead and split this up. I'm just going to write out this step. You don't have to. This is equivalent to 2n plus 3 times 2n plus 2 times 2n plus 1 factorial. All right, so factorial are really easy to deal with. All you have to do is keep subtracting that constant. All right, so now things cancel. So x to the 2n cancels with that. X cancels with x cubed to become x squared. All right, so after all that work, I'm finally left with, I'll go up here, the limit as n approaches infinity of, I have x squared, I have 2n plus 3 times 2n plus 2. All right, and this limit equals 0. So what that tells me is that, and remember, 0 is less than 1. So that means that this converged. Okay, this was convergent. So that tells me that my radius of convergence is infinity. Okay, that means that this converges for any number you can plug in for x. Any number you plug in for x, you're going to get 0 here, which is less than 1, which means that it converged by the ratio test. So my radius of convergence is infinity, okay, which means that my interval of convergence is negative infinity, to positive infinity. All right, one last example. So we'll go ahead and write out our limit. Right, so you hopefully by this time kind of know how some things work. Right, so some things are going to cancel. This will cancel with, so this deconstructs to n plus 1 times n factorial. Those will cancel. So I'm just left with n plus 1. Right, this and this will cancel. So I'm just left with x minus 3 to the first power. So actually everything in my denominator canceled out. Right, so if I evaluate the limit, I get infinity, which is greater than 1, which as you know, that means I diverged. Okay, this means divergent. So that means that my radius of convergence is 0, which means I only converge at my center, which is 3. Okay, I only converge for values of x that are 3. Nothing else. 4, 5, 6, nothing works except for 3. All right, that's it for this. See you all later.